We're going to start talking about global winds by talking about what causes large wind cells to move wind around the world. So you just watched in a brain pop, hopefully, discussing how the sun's rays heat certain parts of the earth more than they heat other parts of the earth. So obviously we know that the equator is hotter than anywhere on the planet, so the equator receives more of the sun's direct energy than anywhere else on the planet. So this is why you see the arrow that says hot. Well, what happens to warm air? We talked about this when we discussed convection. So we know that warm air rises. Here at the equator, we have this huge push of warm air that, depending on which region of the earth you are, the northern hemisphere or the southern hemisphere, here in the northern hemisphere it goes up towards the North Pole, and here in the southern hemisphere it goes down towards the South Pole. Now, we also know that as warm air starts to cool off, it condenses, pumps together, and then starts to fall back towards the earth. Well, some of that air starts to fall back towards the earth here at 30 degrees north. So you have this large push of air that comes down at 30 degrees north. This is known as a high pressure system because you have so much air coming down. Whereas here at the equator, you have a low pressure system because you have this huge push of air up. Okay, well, some of that air is going to fall at 30 degrees north and then again at 30 degrees south. And I'm trying to draw these arrows in for you guys so that you can see the same arrows that are underneath. Some of this air will maybe start to fall back down here at 60 degrees north and 60 degrees south. However, there's also another rise of warm air at 60 degrees, which is like flying a paper airplane. So you can throw the paper airplane and it'll stay aloft for a certain period of time, and then sometimes it'll start to dip back down, but then catch an updraft and then start to fly back up again. So at 60 degrees north, that's what's happening to the air, is it may start to fall back down here, but then it catches another updraft and it carries it all the way back to the poles, where, as you can see, the air is pushed up, because we said at 60 degrees it comes up, and then it'll also come back down at the poles. And the same thing happens here, where it goes up, and then it comes back down to cool at the poles. Now, what happens here between 30 and 60 north and 30 and 60 south is a little trickier. If you guys have ever seen three gears moving together, you'll notice that the two outside gears are moving in the same direction, which forces that gear in the middle to move in the opposite direction. 30 degrees north and south, in between 30 and 60 degrees north and south, these two major cells of air that are moving in the same direction help to cause this air in these sections to move in opposite directions. And so we can put these arrows in for you guys here. Now, that's not the only thing that causes winds to move around the earth. There's also something called the Coriolis Effect. And the Coriolis Effect is caused by the Earth's rotation. And so as the Earth is rotating, as opposed to winds just moving north or south, directly north or south, the Earth's rotation causes winds to bend. And so you guys need to remember that, so I'm going to write that on the board. Winds bend. And bada bing!